Hi guys, hopefully you're all familiar with plotting a single complex number on the Argand diagram. Today we'll be talking about subsets, which are different. Subset means that you plot all the points which satisfy some given condition. Today we'll be talking about 4 different cases. So if you are given the modulus between the complex number z and another complex number a plus bi equal to r, then the result will be a circle with center A, comma B, and radius r. For example, if you got modulus of z plus 2i equal to 3, then if you just follow the modulus formula, you will have square root of x square plus in bracket y plus 2 square is equal to 3, and then you square both sides. So now you got a circle with center 0, comma -2, and radius 3. The next equation is given by argument. Argument just means the angle. So if you got the difference between the complex number z and another complex number a plus bi, and the argument of that is equal to theta, then the result will be a straight line with endpoint A, B. Keep in mind that this endpoint is open, and the slope or the radian is tan theta. So example, argument of z plus 2i equal to pi over 3. You do rise over run, so the rise is y plus 2, and the run is x. So that is equal to tan of angle pi over 3, which is root 3. So you rearrange that and work out the equation of the straight line. You can also do this on CAS, but when you go solve, you don't do C-solve. You do normal solve for subsets. So arguments on CAS, you need to say angle, okay? Do angle equal angle z plus 2i equal pi and 3, and then solve for y. And that is your straight line. The next equation, so this time you got two complex numbers, two fixed complex numbers, a plus bi and c. I should say c plus di. And basically your complex number z, which is x plus yi, that complex number is equal distance from these two complex numbers. So your result would be a perpendicular bisector of the line joining the two complex numbers. So an example is given here. You can do by hand as well. You can try later on. For on CAS, this is what you can do. You go normal solve, not C-solve again. And then you put that in solve for y. So this one is the perpendicular bisector, basically, of the line joining the point -1 plus 2i and the point 0 minus I. And the last form, you got the product between z and the conjugates equal to r squared. It's very simple. This one is just a circle of center 0, 0 and radius r. Okay, Heffernan exam 2. So the first part asks you to plot these two numbers, which are straightforward enough. And then the next part said these 2 points together with the origin form or lie on the circle of this form. And you asked to basically work out what A and B are. A lot of the time symmetry is useful here. So C and D have the same imaginary parts and they lie on the same circle. So you know that the radius must be along the imaginary axis. But how do we work out, what the center is? So we know that the center is on the imaginary axis. That means real is 0. So that's why you can let the center be 0 plus ai. Now we need to work out what a is. So we know that all these 3 points are equal distance from the radius. So let's pick, say, the center and the origin. Okay. So you work out the distance between these two here. So you use the distance formula if you like. So we be square root of a square on the right hand side. So this time you choose the center and your point D, for example. Okay, applying the distance formula. Remember the center is given by 0 plus ai. So you would have square root of 0, take away 1 square, plus I, take away negative root 3 all square. And then on CAS, you can solve for I. In this case, B is the radius, and you can say from here, yeah? So it just happened that the radius is the modulus of I in this case. Another example on subsets. So you are asked to sketch Z times Z bar equal to 4. So we discussed about this before. You end up with a circle with center 0, 0 and radius 2. So this one is Z times Z bar equal to 4. And next, so you want to sketch that. We didn't cover this on the first slide, but you can always derive things from scratch. Or on exam 2, you can use CAS to solve as well. Firstly, you need to define Z as x plus yi. And then you go solve, normal solve. Okay? So you do the modulus here. And Z plus Z bar, so you can do CO and J in this case for conjugate. And then just solve for y. So now you've got y equal negative absolute x or y equal to absolute x. So essentially, it just means y is equal to plus minus x. So these two lines, both of them. Okay, another example, which is the last example. So you're given the Cartesian equation y equal negative x over root 3. We want to find the area formed between this line, which is the blue one, the graph of z times z bar equal 4, which is this circle here, the line represented by argument z equal to pi over 3. You can go and solve for that line on CAS if you like, yeah? So y turned out to be root 3 of x, which is the red one. And the last thing, real z is root 3. So that is a vertical line, okay? So now we want to find the area. Basically, it's this area here. This is our area here. There are a few ways you can do it. I'm using calculus here, but you can also use the area of the sector and area of segment as well. So I split this area up into 2 regions. You see from here? So one region is from 0 to 1. From 0 to 1, this red line is above the blue line. And the equation for red line is root 3x. We found that one before. And then the blue line is given by this. You see top minus bottom always. So it will give us this area here. And then the second area from 1 up to root 3. Okay. So 1 up to root 3 here. So in this case here, so we know that the semicircle is on top. So you take this minus a bottom one, which is given by negative x over root 3. And then you add the two areas together to get the total area. Okay, the last part. So from the look of it, it looks like it's a difficult problem, but it's not. You got z equal to k times z bar, and we want to find k in the polar form. Okay. So in this case here, your angle from the previous parts. So your angle is negative pi over 6. So this one is your complex number z. And then if you want complex number z bar, then you just change the angle from negative pi over 6 to pi over 6. The radius stay the same. Okay. And then you rearrange that, and then you work out your k. Because k would be r6 negative pi over 6 divided by r6 pi over 6. So now you basically take the difference between the two angles, and the r will cancel out.